We had some homework from a long time ago before our 10-day break. Page 478, questions 1 and 2, both on the law of conservation of momentum, which says, remember, in an isolated system, momentum remains the same. Momentum can't be created, it can't be destroyed. So in an isolated system, we're always going to have the same amount of momentum, both before and after some kind of interaction. What do we mean by that word isolated again? In an isolated system. Yep, Lewis? Good. You got no external forces acting. You're not allowing any energy to come in or out of this system to cause something other than the interaction itself to come into play here. So basically what we do, usually, to have an isolated system is look at the interaction immediately before and immediately after. Okay, that helps us to avoid friction or air resistance or anything like that, any kind of extra object that's coming into play. Okay, if we look at immediately before and immediately after, although there may be friction, okay, it's so soon that friction hasn't had a chance to play a serious impact. Okay, so typically, again, what we want to do is look at just before and just after the interaction. Now, how do we do it? Well, we know that if there's no loss or gain of momentum, then the initial momentum will always be equal in an isolated system to the final momentum. So Pi is equal to Pf. Now, what you do after this point is just count up your objects both before and after the collision or the explosion. And then write an MV term in for each of those objects. So if you got two objects colliding together, then we're going to say M1 V1I plus M2 V2I. If they stick together, then you're just going to say MVF. If they bounce apart from each other, then it would be M1 V1F plus M2 V2F. However many objects you have after the collision, you got a term for each of those. We had two questions on 478. Either of those that we need to go over here? Nobody's asking me for either one, then I'm just going to pick one because we want to kind of get back into the groove of it by doing an example here. Rucker? Number one? Okay. So we'll look at number one then. It says a 0.25 kilogram volleyball is flying west at 2 meters per second, strikes a stationary basketball dead center. The volleyball rebounds to the east at 0.79 meters per second. All right. Just picked up my red pen. Did you notice that? Okay, what do I want to draw attention to here? Right? Yeah, the opposite directions. I saw the word west first, and I almost picked up the pen to circle that. But then, you know what? It doesn't really matter if it's west. What matters here is that we've got an east and a west in the same question, right? If everything is west, then make it positive. It's fine. Doesn't matter. Or make it negative. It's fine. It doesn't really matter. But if you've got an east and a west, then it's important that we circle it because we want to draw attention to the fact that something's got to be positive, something's got to be negative. We want to find the velocity of the basketball immediately after impact. All right, let's write down some givens now. Okay, this is going to be M1, the mass of the volleyball, and we're going to say that the initial velocity of the volleyball, V1I, is 2 meters per second to the west. Let's write in the word negative here, just as another reminder. In the end, it doesn't hurt to have extra reminders here. Okay, I already circled it once. Hey, that might be enough. Okay, but if I write the word in again, I'm even less likely to forget to put the negative in there. Strikes a stationary 0.58 kilogram basketball. That's going to be M2. We're going to say V2I is 0 because it's stationary. The volleyball rebounds at 0.79. What's that going to be? V1? Or is that going to be V2? Dallas, is that V1 or V2? Good. It's V1, V1I or F? Good. V1F. The volleyball, object number 1, rebounds after the collision. Okay, V1F, 0.79. And it's going to be positive. We want to find V2F. So let's do what we do. It's a collision. Pi equals Pf. Now, remember what I said before the break? You encounter one of these problems. You could, if you wanted to, use impulse. But if you use impulse, you got to be careful to pick one object. Analyze either the volleyball or the basketball, not both of them at the same time. It makes sense usually in these questions to do conservation of momentum, but impulse is valid if you want to try it. It's valid, but just make sure you pick one object or the other. All right, using conservation of momentum, we're going to say, how many objects do we have? How many objects do we have before the collision takes place here? Yeah, we got two. We got a basketball and we got a volleyball. So two objects, two terms. M1 V1 I plus M2 V2 I. Now, how many objects do we have after the collision takes place? Two. So we're going to have two terms again, right? M1 V1 F plus M2 V2 F. Hey, can I cancel those masses out? The rule for canceling is it's got to appear in every term, right? Mass appears in every term here, right? Can I cancel it? Why not? Because it's two different masses. Is there ever a time in one of these questions where I could cancel out the mass? Ever? I see some people doing this. No, there's never a time. Anybody say there is a time? Yes? Okay, that's not really canceling, but I know what you mean there. If the velocity is zero, then I can just scratch out the entire term because anything times zero is zero. Yeah. So it's not canceling, but it has the same effect. You're getting rid of it, sure. Ever a term when I could cancel out all of the masses? Jeff? When they're the same mass. If two basketballs collided with each other instead of a basketball and a volleyball, right? It happens from time to time where we can do that. Listen, if it does happen, you don't notice, you can cancel, that's okay. You'll still get the right answer. It just means a little bit of extra work than you have to do, that's all. All right, let's plug in some numbers here. 0.25 times V1I, which is 2 meters per second. And this is stationary. Somebody said, I think it was said, we can get rid of that when one of the velocities is zero, right? So I'm just going to scratch that out. I won't even bother putting that new term in there. M1 is 0.25 again, times V1F is 0.79, plus mass 2, which is 0.58. I think that was 0.58. Yep. Times V2F. Is this right? The hands go up. At least a couple of the hands go up. A couple more going up. Well, that must mean there's a mistake if the hands are starting to go up. Jazzy, what's the mistake? What's wrong here? It's a small mistake, but a very important mistake. No? Janessa? V1I has to be negative. Listen, we can't forget that. We circled west in red, and we identified in blue here that V1I has to be a negative number. Right? We might still forget. Even after doing that, we might still forget, but we're a lot less likely to forget if we've drawn attention to it. All right, let's do some math here. 0.25 times negative 2 is negative 0.50. 0.25 times 0.79. 0.1975 plus 0.58 V2F. You see, if we leave that as a positive number, everything looks almost the same at this stage. But when we take this number over to the other side by subtracting, then it's going to give me a completely different number at this point if I don't put the negative on the left-hand side. So let's take it over by subtracting. I end up getting negative 0.6975. Again, if I had made that positive over here, then I would have gotten what? What would it have been? Positive 0.3-ish, which is obviously going to give me a completely different answer then. V2F, do the math. Works out to be negative 1.2 meters per second. Now, they said 1.2 to the west here when we look at our answer here. My answer right? Yeah, Genesis say yes. So the negative obviously means to the west, right? We've assumed that east is positive and west is negative there. Guys, I've mentioned this to you. We've only been here for 2 weeks, but I've mentioned this to you before already. Okay, when You guys will write the diploma exam on June 25th at 9 o'clock in the morning. Okay. I will get to see the diploma exam on June 25th at 10 o'clock in the morning. You'll be writing for an hour furiously before I even get to see it. When I see it, I'll read it. I'll spend about 15 minutes going through the exam. I won't do the exam. I'll just sit and look at the questions, and I'll kind of, in my head, categorize the questions into 3 categories. Okay, this one's a very doable question, like a really, not necessarily easy, but a real doable question. Okay, second category would be kind of tricky. There's some things in there that could throw people off, but if you're really paying attention, you know your stuff, you'll get this question. And then the third category is, holy cow, that's a tough question. That's a really tough question. And there might be a handful of you who get it right, but a lot of you will get it wrong. Thankfully, there's not a lot of those really, really hard questions. There is a lot of those medium questions. There's some of the easy questions, some of the hard questions, and a lot of the medium questions. Okay, this is what I would consider to be somewhere in that, not necessarily the real easy, but it's kind of in between easy and medium. Okay, we can get this. Okay, when I look at that, I say, everybody should get this question. But you know what? Not everybody will get it. Why? What are people going to do to mess up on this question? I guarantee you, if you see this, people are going to mess up this question. Most of you won't, but some of you will. What's it going to be, Brad? It's going to be to forget to put in the negative. Okay, I guarantee it. Some of you will do that. Okay, don't be that person to forget that negative. All right, we okay with that? Let's take a look at our last example for this topic on page 475, 9.5. It says, a 75 kilogram hunter in a stationary kayak. So you got to picture this now. Okay, everybody picturing it in their mind right now? Visualizing it? There's a hunter in a kayak. Are you visualizing it here? Yes? Really? Do you see it in your head right now? Does the hunter have a life jacket on? No, he doesn't. What color jacket is he wearing? Brown jacket? Really? Bearskin. Oh, in a kayak. Oh, all right. Braden, what color is the kayak? Okay. Does he have, Braden, does he have like oars or like that paddle thing? Yeah. What color are the ends on the paddle? You're not even thinking about that, right? He's got a brown oar to match his bearskin jacket. Is that it? Okay. See it, guys. Okay. Visualize it. See it. The guy's sitting in the kayak. Okay. The guy is 75 kilograms. Oh wait, he's got a harpoon. The harpoon weighs 0.72 kilograms. Did you see the harpoon, Braden? Did you see the harpoon? It throws the harpoon at 12 meters per second to the right. The kayak is 10 kilograms. What is the velocity of the kayak and the hunter immediately after the harpoon is released? Okay, so picture this again now. Okay, we know that the guy's wearing a brown bearskin jacket, no life jacket. That's not very good. Okay, he's got what color was the kayak again? Red? Red and brown kind of clash a bit, don't they? That doesn't. Do they go together? Do they? Sorry. A darkish red. Okay. Okay. Like kind of like a blood red. Okay. All right. So the guy's in the kayak. He's with the harpoon. He throws the harpoon. So the harpoon goes one way. What goes the other way? The kayak and him. So the kayak and him never separate. We're given the mass of the kayak and the guy separately here, but those masses never come apart. So that 75 kilogram hunter and the 10 kilogram kayak, let's put them together and let's leave them together. They're trying to mess us up here with separating those masses. What they want to do is have us call M1 the mass of the hunter, M2 the mass of the harpoon, and M3 the mass of the kayak. We don't want to do that because the hunter and the kayak are together at the beginning, they're together at the end. They might as well be one. The hunter that's wearing a brown bearskin jacket is one with his kayak, and he never separates from his kayak. Now, the harpoon, on the other hand, he does separate from, right? He throws that, harpoon goes one way, him and the kayak go the other way. So let's write down our givens here, because it's kind of a little bit awkward maybe to circle things here, just because a couple numbers are combined. Let's write down our givens like this. Mass 1, we're going to call 85 kilograms. That's the hunter and the kayak. We're combining them. We're leaving them together because they never separate. The harpoon, we're going to call that M2. Really, although we're given 3 masses here, you understand we only really have 2 masses. The hunter and kayak combined, and then the harpoon, which separates from the hunter and the kayak. All right, we've got a velocity here, 12 meters per second. What velocity is that? Is that going to be V1 or is that going to be V2? V2, good. It's the velocity of the harpoon that he throws. Now, is that going to be V2I or is that going to be V2F? Get on V2I or V2F? V2F, good. That's right. Yeah, that's right. Right after he throws it. Remember, you're picturing it here, guys. You're visualizing it. You're seeing it. Okay, everybody's visualizing that beautiful bearskin jacket on the hunter right now, and this harpoon being thrown off. Okay, the harpoon goes off at 12 meters per second. Bless you. That's after the event. Okay, that's the final velocity of the harpoon. We want to find V1F. Is there anything else that we're given here? If we maybe read between the lines a little bit? Anything else that we have here? Casting? V2I would be 0, yes. Anything else? V1I would also be 0, right? The guy, the kayak, and the harpoon are all at rest before he throws it. So we're just going to say, we're not going to say V1I equals 0 or V2I equals 0. Let's just say VI equals 0. Okay? It's okay to separate them like that, but we don't need to separate them because they're all one object before he throws the harpoon. Let's just say VI equals 0. All right. Now, there is an impulse in this question. In fact, there's 2 of them. There's an impulse given to the harpoon that's a positive value. There's an impulse given to the hunter and the kayak that's a negative value. If we add those together, they give me 0. Right? The total initial momentum is going to be 0 here. So if one gains momentum, the other's going to lose momentum. One's got a positive impulse, one's got a negative impulse. We could do it that way, sure. But it probably makes sense in a question like this to say PI equals PF, the law of conservation of momentum. The initial momentum is 0. There is one object, the harpoon, hunter, kayak combination, but its total velocity is 0. So let's just say, instead of writing in a bunch of letters with subscripts, let's just say the total initial momentum is 0. Now, if the guy, the kayak, and the harpoon were moving before he threw it, then we wouldn't be able to say that, would we? We'd have to say M times VI, whatever VI is. Here, we're still really saying M times VI, but VI is 0, so we'll save ourselves the bother of writing down the term there. After he throws the harpoon, after he throws it, how many objects do we have? Jack, how many objects do we have after he throws the harpoon? 2, right? Not 3, what a lot of people are going to want to say here, but 2, you're right. It's going to be M1 V1F plus M2 V2F. Cancel out the masses there? No, we can't, because they're not the same, right? If they're the same, you can cancel them out. If they're not, then don't cancel. M1, 85 kilograms. V1F, that's what we're looking for. M2 is 0.72 kilograms, and V2F is 12 meters per second. All right, quickly, before we calculate this number, stop if you're punching it into your calculator right now. Just pause for a second. What do you predict the value of V1F to be? Don't give me an exact number. Just tell me whether you predict it to be greater than 12, less than 12, quite a bit more than 12, quite a bit less than 12, a little bit more, a little bit less. Like, give me a ballpark for it here, Rucker. Okay, then don't give me an answer here. 70? Why would you predict it to be a lot less than 12? Good. If the hunter and kayak have the same momentum as the harpoon does, and they have to, right? Then, and they have a lot bigger mass, then they have to have a lot lower velocity to have the same momentum. So we get an answer for this. Let's make sure that it's a number that's a lot less. And if it's not, then well, we better try again because we know we made a mistake. All right, so 0.72 times 12. Take that over to the other side by subtracting. Divide it by 85. What do we end up getting? How about negative 0.10? Yeah, or 0.10 to the left is fine, yeah. So it is quite a bit less, right? It's a lot less, and it's opposite direction, right? It makes sense that if you throw the harpoon one way, then you're going to go the opposite way. Not very fast, but you're still going to go the opposite way. Makes sense? Really the same question as we just did a minute ago. Right, that homework question that we had, except that this one, the initial momentum was 0 because it was what I call an explosion, even though it's not literally an explosion. Same kind of idea, right? Sometimes, guys, sometimes the problem that we have with questions is just keeping numbers straight, keeping givens straight. Okay, this is one of those questions that sometimes creates that problem where we have 3 different masses, but we only really need 2 masses. We got to combine a couple of things. Where, you know, what's final, what's initial, what's V1, what's V2, and sometimes it does help us to see that in our heads. Maybe draw a picture of it on paper. Maybe visualize it in our heads. And really, I mean, really, it's a test. It's test day. Do we really need to picture what color his jacket is? No, of course not. Okay. But is it helpful to see it, to actually visualize it in your head? Yeah, it is. It is helpful sometimes, especially in a question like this where we got those 3 different masses. Okay, we see it in our heads. It becomes a lot easier to see why the hunter and the kayak become one object and they stay as one object. Okay, so don't try to take shortcuts. If it takes you 30 extra seconds because you're visualizing it, so be it. Okay, if you got a better chance of getting the question right, then do it. Okay, I want you to work on these 2 questions right now. Same types of questions, explosion type questions. See what we can do with those, and then we'll take a look if we have to in a few minutes.